Here's the scenario. You have several pipes on a rack, and they're all at different elevations and they're all sloped. Now they all have to be connected. Now you can have them all in one model and do your connections, or they may be separated by service, each in their own model. So I'm going to show you a slick and easy way to make the connections without having to draw the same thing twice, which is kind of a cardinal rule in AutoCAD. Never draw the same thing twice. What I've created here is fitting assemblies that I've made blocks out of and rope block them out. Before I get started, I want to explain how I came up with that 0.5729 degrees. This pipe is drawn at a 1% slope using Cadworx slope method meters, and then 10 millimeters per meter. And if we do a measure of the angle of this sloped line and this perfectly horizontal line, we get 0.5729 degrees. That's where that number came up from. Now, before I get into how to rotate these, this is a slope line, and we'll drag, and a slope fitting, we'll drag this off here and we'll slope it 10, pick, enter, enter. All right, there's our slope. So let's look down the end of this. That fitting is in there perfectly vertical. This is sloped. This is a 90-degree fitting. This cannot be fabricated. This pipe is going to go into that 90-degree socket, 90 degrees. Right now this is greater than 90 degrees. The contractor is going to have to put another fitting in here someplace to rotate this to that angle. So don't do this because it can't be built. The proper way to do it is up here. You rotate the Y, you rotate this whole assembly 0.5729 degrees that way, which gives you your 1% slope here. But before you do that, yeah, that's correct. You want to rotate down the longitudinal axis of the main first, and then rotate the main to its slope. And I'll give you a quick demonstration of how this works. We'll look down the end of this pipe. Get in the XY plane. We'll rotate the whole thing. And this we rotate down. Now, I draw a vertical line from that point. And I use the end point of that as my rotation point, because we're not going to rotate this pipe. We're going to rotate the fitting and this. And the reason we do that is because if you catch the wrong rotation point, your lines come out skewed, and this one is up. I'm not going to take the time to show you here, but if you want to test it on your own, what you do is draw a line over top of your center lines. And the reason you do that is if you try to list a center line, it doesn't give you the information you need. And then you list that center line. And it should be an even quadrant, 0, 270, 180, 360. Angle in the XY plane. This is the angle from the XY plane, or the slope. And there it's 270, it's an even quadrant. And then the angle from the XY plane, or the slope. That's how you check to make sure. But you want these two lines to be on an even quadrant to ensure that there's 90 degrees between those two. And then we right block them out. When you right block it out, you want to set it, all of your blocks to layer 0, so that when you insert them and explode them, they take the inherent layer that you're currently on. And next I'll show you how to use them. Oh, about making these blocks, or these fitting assemblies. The size or the spec that you're using is not important. You can change the spec, you can change the size, you can change the line number. However, you cannot change the material. So if you have more than just PVC Schedule 80 pipe in this, you have to make a assembly, fitting assembly for each type of pipe. Like there's stainless steel in here. If you were going to do any connections in that, you got to make a fitting assembly for stainless steel pipe because it's butt welded. All right, next we'll use them.